Over the past few weeks, I've been working on a new project after a discussion with a friend. They were using a commercially available game engine and wanted to add wind into their project. They were telling me how difficult they were finding this, and I decided to see if I could come up with a simple method that would create a convincing wind effect that could be used in a real-time application. So the brief of the project is to create a convincing wind effect using the simplest method possible and have to allow for control over the direction, power and speed of the wind that could work in a real-time application such as a game. In today's video, I'll be showing you the result of my work and going through the method that I used. So here's the code for my proof of concept. I have stripped out some of the code and placed it into a parent class to make this easier to read. This will not affect how the project runs. In our scene, we will have two models. The first model is a flat quad, 50 units wide and 50 units deep, to act as a floor. The second model contains all of our blades of grass that we will render in the scene, and there will be 50 blades of grass in the X direction and 50 in the Z direction. Each blade of grass is made up of 12 vertices and separated into 5 segments of height. It has been designed this way so that I can add a nice curve to my blade of grass as it is affected by the wind. This would not be achievable with a single flat quad with only 4 vertices, as there wouldn't be enough detail in the model to achieve it. Also in our scene will be our wind effect. The wind effect uses a vertex displacement map to decide how much each vertex should be displaced at a particular point. When rendering our grass, each blade will sample the map at a point based on where it is in the scene and use that information to decide how much to displace itself. Our vertex displacement map is a simple texture, so it will save colour information. In computing, colours are stored as 3 component values, red, green and blue. Sometimes they'll have a 4th component known as the alpha value. In a 3D world, there are 3 axes of movement, X, Y and Z. This means I can use my colour component values as displacement values just by mapping each component to an axis. Colour values are usually between 0 and 1, which means I can't immediately use negative displacement in my scene. However, if I take away a value of 0.5 from each component as I read it from my map, this will give me values between minus 0.5 and 0.5 for displacement. This means I can move each vertex around in any direction I choose. For example, a colour of 1, 0.5, 0.5 in my map corresponds to a displacement of 0.5 in the x-axis, and a colour of 0, 0.5, 0.5 in my map corresponds to a displacement of minus 0.5 in the x-axis. The vertex displacement map is generated while the program is running. This is done by using a particle effect. By using a particle effect, I can fulfill my brief as I can move the emitter around the scene to decide where the wind originates from. I can rotate it to change the wind direction. And by changing its settings while the program is running, I can have effects on other things such as the speed and the power of the wind. I can do this by changing the colour of each particle that the effect handles. Each particle will have a colour based on the direction it is travelling in, and an alpha value based on the power that it represents. This means I have a simple method of creating a wind effect in my scene. The particle effect will render directly into the displacement map. Now that you know how my method works, let's see it in action. So here's our field and the wind's coming in now. I can change the direction the wind is travelling in. And currently the wind speed is linked to the wind's power. So as I decrease the power, the speed will also decrease. As I increase it, both the power and the speed will increase. So we have a working wind effect for our scene, but now I'd like to improve how it looks a little bit. It looks quite sparse and empty, and it looks quite uniform, as if it's been hand planted that way, which isn't impossible, but it doesn't look like a natural effect. But there's a few simple things we can do to change that. The first thing we can do is double the number of blades of grass we will get in our x-axis and our z-axis, so that we have a nice dense field of grass. Secondly, we can change each blade of grass just a little bit to change how it looks in the scene. This should make each blade of grass look more unique and make things look less uniform. We can do that in the setup blade function down here. This is called for every blade of grass we create, and returns a transformation matrix that will affect how each blade looks in the scene. The first thing we can do is set a random height for each blade of grass. We can achieve that by setting a scale factor for each blade of grass. We want to leave the x and the z scale the same as it is, but let's add a random value for the y scale. And we'll go for values between 0.8 and 1.0. This should give us a nice variation of heights of grass in our scene. Next, we can change the orientation of the blade of grass. This means different blades of grass will face in different directions. We can do this by applying a rotation to each blade of grass. Again, we'll use a random value, and we'll go between -55 and 55 degrees. Again, we only want to affect the y-axis. Let's run this now and see what our scene looks like. So we have a nice dense field of grass where it all looks a little less uniform. Wherever it still looks a little bit hand planted, you can see the lines in between each blade of grass. There's a few things we can do about this. Back in our setup function up here, in the create grass function, there's an extra value we can add called the cool value. This will take away a percentage of the grass in the field as it is being created. Setting a value of about 60% should give us some nice gaps to make the grass a little bit less dense, but also have a nice random natural effect. The next thing we can do is add an offset to each blade of grass from its origin. Again, we'll use a random value, and we'll have a value between -0.25 and 0.25 in the x direction. We'll leave it where it is in the y direction, and do the same thing in the z axis. So we'll run this again now. And we have a nice random field which looks dense in some areas and less dense in others. Each blade of grass looks a little more unique than all the others. There's still one thing we can change though. Let's go into our shader. So this is the graphic shader that renders each blade of grass and applies the displacement to it. It is made up of a vertex shader and the fragment shader. Our fragment shader doesn't do very much. All it does is colour each blade of grass based on the height of the vertex that is passed into it. This means we have a nice curve from black to green for each blade. Our vertex shader does most of the work. So here, we sample the displacement map and take the colour information from it. Here we record the height of the vertex and pass it into our fragment shader. We only apply our effects where the vertex displacement map isn't transparent. We record the power of the wind here using the colour's alpha value, and here we calculate the displacement. We're only interested in displacement in x and z, so we can ignore the y displacement. The calculation is simple. All we do is we take the component value of the colour, take away 0.5, then factor in the power of the wind. We do this for both the x and the z component. We then apply that to the vertices, the vertex position. So here, for example, we're taking the original vertex position in x, adding its displacement, and then factoring in the vertex's height. This means the higher up the vertex is, the more it is affected by the displacement, so that vertices at the base don't move, and vertices at the top of the blade move the most. For the z-axis, we take away the displacement because the negative z-axis points away from us. We'd like to give each blade of grass a nice curve as it's hit by the wind, as you would expect in nature. We can do this by using a factor of the square of the height of the vertex rather than just the height of the vertex. We can add that in here. So delta S will be equal to delta squared. We then factor in delta S rather than delta. Save and build that. When our wind is applied, the grass will curve. I've now added in the render target to the scene that shows the vertex displacement map. In the top right corner, you'll see the vertex displacement map as it's being generated. You'll see the particles change colour as they change direction. And as I turn the wind effect down, you'll see it fade to transparent. And I can turn it back up and you'll see the colour come back again. I just want to take a little moment to explain what's going on in the setup blade here. You've probably seen these two objects, Nova Transform and Nova Random, and you're probably wondering what they are. Nova Transform represents a transformation matrix. In this case, it's a model matrix which is applied to each blade of grass in our scene. Nova Random is an object that returns a random number in the range specified by the function. Nova is my self-developed game engine. I've been working on Nova in some way, shape or form for the past few years, and it is now in a position where I'm finally ready to show it to you. And I will be doing so in a future video, along with other projects that I've developed with Nova. Thank you for watching this video. I hope you've enjoyed it, and I hope it's been informative. If you'd like to know more, please go to my website, where there'll be a blog post about this project with more information. If you have any questions or comments, please feel free to leave them and I'll try and get back to you. Please keep an eye out for future videos where I'll be showing you more about Nova and what it can do. Goodbye for now.